Hello everyone, I'm Paul and today we're solving problem 837, new 21 game. Here it says this is medium, but this is actually a very tricky one, so we'll go step by step. We are playing a game here. We start with 0 points and we need to draw numbers. So each time we get a random number in the range from 1 to max points. We are given this variable max points, and the game ends when we get k or more points. And our job is here. We need to return the probability that we get n or fewer points. Let's say we get this input. This is max points, n is 3 and k is 2. We start with a score of 0. And from here we can get a random number of points in the range from 1 to 4. So next we can have 1 point, 2, 3 or 4 points. Now we are looking for n or fewer points. This means 4 is not useful for us. And for example here 2 is equal to k. And remember, whenever we reach k or more points, the game stops. So here the game stops and 2 is smaller than n. So this is a successful case. And here, this is also a successful case. 3 is in the range between 2 and 3. Now from here we have 4 more choices. Next we can have 2 points, 3 points, 4 points or 5 points. These and these are greater than n, so these are failure cases. And these are successful cases. And we need to return the probability to win. So here in this level we return 2 out of 4 cases, and 2 divided by 4 is 0.5, so here we have the value 0.5. And at this level we do the same. Here we have a successful case, so this is a 1, here we also have a 1, and here we have a 0. So we add all of these values. We do 0.5 plus 1 plus 1 plus 0, and this is 2.5. divided by 4, this is 0.625. So finally we can return the probability to get n or fewer points, meaning this. Now this works, but the problem is down here in the constraints. We know that max points is smaller or equal to 10 to the power of 4 and k is smaller or equal to 10 to the power of 4. And this approach requires time complexity of big O of k times max points, because at each level we get this amount of nodes and the height of this tree is given by k. So this is overall k times max points. And this is a very big number. We can't handle 10 to the power of 4 square. This will throw time limit exceeded. So we need to think about something more efficient. So as we saw in the decision tree, we need to keep track of different results for different scenarios. And whenever we are doing that, we are talking about dynamic programming. Here we will also use sliding window. So let's see how this works. This is our DP array, and this has a size of max points plus k. So let's see what can we fill here. We know that anything greater than n should be a 0, because we are looking for the probability to get n or less points. We also know that if we get k or more points, the game stops. So this is the range where the game stops. And after the game stops, if our score is n or less, we have a successful case. And the result for a successful case is 1. So this will also be 1. So this is the initial DP array, and now our job is to fill this. And what this cell represents is the probability of getting a final score smaller or equal to n if we start from this score. So remember our decision tree a few minutes ago. We have 4 different scenarios here, and these are the 4 different scenarios. We need to sum the values for each of these scenarios and divide this by the amount of nodes, meaning max points. So we do 1 plus 1 plus 0 plus 0, this is 2, divided by max points, meaning 4, this is 0.5. So this is the value we need to put here. And now we are in this cell, meaning now we will get the probability to end with a score of n or less if we start from a score of 0. Now remember that here we were looking at this window. And given that now we are here, we want to move this window one step to the left. So now we are looking at this window, and we can do the same as before. We get the sum for the values here. This is 2.5, and we divide this by the amount of nodes, meaning 4. And the result for this is 0.625. So this is the value we put here. Now it can be very expensive to always take the sum of the last window. Remember, before we took the sum of this window, now we are taking the sum of this, and so on. So we can have a variable to store the sum for the current window. We will call this window sum, and this will initially be the sum for the values in the first window. In this case, 1 plus 1 plus 0 plus 0, meaning 2. So for example, if we are here and we are trying to get this value, we take the current window sum divided by max points, and 2 divided by 4 is 0.5. Now we are here, so we need to update this window sum value. We need to add this and subtract this. So we do 2 plus 0.5 minus 0, and this is 2.5. So our new window sum is 2.5. And to get this value, we just do 2.5 divided by 4, and this is 0.625. So finally we reach the end of this loop, and we return the first value of this DP. Remember, this represents the probability to get n or fewer points if we start from a score of 0. Time complexity for this approach will be big O of max points plus k. So now let's go with the code, and hopefully you will get the idea. First, we know that if k is 0, the game is stopped, meaning the probability to get n or fewer points is 100%. And similarly, if we do k plus max points and that's smaller or equal to n, this means we will never be able to exceed n points. So in this case, we also return 1. So we say if k is 0 or k plus max points is smaller or equal to n, we just return 1. Else we do the following. First, we have our DP array. This is an array with 0 times k plus max points. And just to be clear, dpi is the probability to win. And remember what win means is to get an amount of points smaller or equal to n from I score. So dpi is this. And first, our window sum will be 0, and now we can say for I in range from k to k plus max points, we are filling our DP and adding values to our window sum. We can say if I is smaller or equal to n, we say dpi is 1 and window sum plus equal 1. And now we can fill the rest of the values in our DP array. Remember, we are iterating this in reverse, so for I in range from k minus 1 to minus 1, this is not included in steps of minus 1. We say dpi is window sum divided by max points. This is the number of nodes in our decision tree. And now we need to update window sum. And remember, we need to add the current value in DP and subtract the last value in the current window. And remember, the window has a size of max points, so we subtract dpi plus max points. So this is how we get the last value in the window. Remember the drawing we saw a few minutes ago. And finally, we return dp0. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.